Hello, today we are going to see Chapter 2, Ethernet. And this chapter contains the following titles. Ethernet is the traditional technology for connecting devices in a wired local area network, LAN, or wide area network, WAN. It enables devices to communicate with each other via a protocol, which is a set of rules or common network language. Ethernet is used to connect devices in a network and is still a popular form of network connection. For local networks used by specific organizations, such as company offices, school campuses and hospitals, Ethernet is used for its high speed, security and reliability. The IEEE, or Institute of Electrical and Electronics Engineers, specifies in the family of standards called IEEE 802.3 that the Ethernet protocol affects both Layer 1, the physical layer, and Layer 2, the data link layer of the Model OSI network protocol. Ethernet defines two transmission units, packet and frame. The frame includes not only the data payload being transmitted, but also the MAC addresses of the sender and recipient, VLAN tagging and quality of service information, error correction information to detect transmission problems. Each frame is encapsulated in a packet containing several bytes of information to establish the connection and mark the start of the frame. Ethernet was first created in 1970 by engineers at Xerox. Back in the day, Ethernet used coaxial cables, but today's Ethernet LAN uses twisted pair cables or fiber optic cables. If two devices try to transmit at the same time, this can cause packet collisions and cause connectivity issues. To avoid these traffic problems, the IEEE developed the Carrier Sense Multiple Access with Collision Detection (CSMA, CD) protocol. This allows connected devices to check if a line is in use before transmitting on it. There are three types of cables commonly used for Ethernet cabling: coaxial cables, twisted pair cables, and fiber optic cables. Currently, the twisted pair cables are the most popular, but fiber optic cable use is increasing, especially in high-performance networks. Coaxial cabling is generally used for cable internet access. Coaxial cabling. A coaxial cable has an inner conductor that runs down the middle of the cable. The conductor is surrounded by a layer of insulation, which is then surrounded by another conducting shield, which makes this type of cabling resistant to outside interference. This type of cabling comes in two types, thinnet and thicknet. Both types have maximum transmission speeds of 10 megabits per second. Coaxial cabling was previously used in computer networks, but today they are largely replaced by twisted pair cabling. Twisted pair cabling. A twisted pair cable has 4 pairs of wires. These wires are twisted around each other to reduce crosstalk and outside interference. This type of cabling is common in current LANs. Twisted pair cabling can be used for telephone and network cabling. It comes in two versions: unshielded twisted pair, UTP, and shielded twisted pair, STP. The difference between the two is that an STP cable has an additional layer of insulation that protects data from outside interferences. Fiber optic cabling. Fiber optic cables use optical fibers to transmit data in the form of light signals. The cables have strands of glass surrounded by a cladding material. This type of cabling can support greater cable lengths than any other cabling type. The cables are also immune to electromagnetic interference. As you can see, this cabling method has many advantages over other methods, but it is much more expensive. There are two types of fiber optic cables. Single-mode fiber, SMF. This uses only a single ray of light to carry data and is used for larger distances. Multi-mode fiber, MMF. This uses multiple rays of light to carry data, and it is less expensive than SMF. It's been more 30 years since the first Ethernet was approved. 1983. This is the year that 10-base-5, thick Ethernet, the very first commercially available variant of what we now call Ethernet, was unveiled. The project took approximately 3 years to complete after the IEEE first commissioned it, but it paved the way for many other changes to come. For example, 1985 saw thin coaxial cables approved, and other modifications were made in 1897, 1990, and 1993. 1995, 1998. Ethernet was RIL, but it wasn't fast Ethernet until 1995. This year also heralded the coming of auto negotiation, which allowed two devices to share data via Ethernet cables. And in 1998, 1 gigabit per second over fiber optic cables was released. This also marked the development phase for twisted pair Ethernet cables. Ethernet reaches the 10 gigabits per second milestone in 2002, just after the USB 2.0 specification was released in 2000. This was around the time when Cat5 cables started becoming more relevant and widespread. Unfortunately, 10 gigabits per second wasn't feasible over unshielded twisted pair cables until 2006. 2010. This year saw, even more, advances for Ethernet. Cat6 Ethernet cables were in use by this time. In addition, higher speeds were achieved by merging lanes of 10 Gbps technology together. Ethernet evolved past 25 gigabits per second in 2016. Not only that, but Cat5e cables, Cat6 cables, and Cat6a cables were all available to use. This was certainly a transition time for many businesses that were switching to higher speed networks. The next Ethernet standard, which will bring us Category 8, has already been approved. It will, however, be a little while before the physical cables catch up. 2020 and beyond, the future holds a whole world of possibilities for Ethernet. Anything from higher GBPs to even terabit speeds could come up within the next 5 years or so. Technology evolves quickly, and Ethernet is no exception to that fast-paced world. The future certainly looks bright for Ethernet development. Ethernet has many benefits, but it also has many drawbacks. Let's take a look at each. Advantages of Ethernet. 1. Relatively low cost. 2. Backward compatibility, and generally resistant to noise. Also good data transfer quality. And speed. Reliability, data security. Disadvantages of Ethernet. 1. Intended for smaller, shorter distance networks. 2. Limited mobility, and use of longer cables can create crosstalk. Also, does not work well with real-time interactive applications. And speeds decrease with increased traffic. Receivers do not acknowledge the reception of data packets. Troubleshooting is hard when trying to trace which specific cable or node is causing the issue.